Hi everyone, in this video we're going to take a quick look at some of the basic rules in naming organic compounds using IUPAC nomenclature. This video is not designed to be including every functional group, so esters for example are not covered, aromatic compounds are not covered, but by the end of doing some of these exercises you should be confident and give you a good starting point on naming organic compounds. My advice would be to have a look at each of the organic compounds, pause the video, have a go at it, and then check your answers with me. One thing I would say is that I will be drawing each of these compounds as a skeletal formula because in some instances it makes it easier to see where the name comes from. Okay, let's start with number one. And number one we can see is a simple alkane, straight chain, no branches. And let's draw this as a skeletal formula. So that will be this compound as a skeletal formula. And the first rule in naming organic compounds is always look for the longest carbon chain, which we can see is, in this case, very straightforward. We just number the 6, which again would be the same 1, 2, 3, 4, 5, and 6, whether we do it on the skeletal formula. So 6 carbons, again you should be aware that 6, the IUPAC name for a compound with 6 in the longest chain is hex, and this is an alkane with no branches, no other functional groups, so this is simply hexane. Should be very straightforward. We're going to move on without any further ado to some more complex ones. So this time we've got another alkane, but this time we've got one with a branch, and again I'm going to draw this as a skeletal formula. So that's 1, 2, 3, 4, and that should be 5, and then we've got a branch. Oops, I'll just do that a little bit better. I've got a branch here. Now this time we need to think a little bit more about which end I'm going to name from. I'm going to number this from left to right, or I'm going to number this from right to left. Now in this case we must number to give the branch the lowest number possible. So in this case I'm going to number it from right to left. So this is now going to be 1, 2, 3, 4, and 5. So you can see that I've got 5 in my longest chain, and I've got this methyl group, this 1 carbon in a chain coming off carbon number 2. So we need to reflect that in the name of the compound, the fact that the alkyl group, this methyl group, is coming off carbon 2. So we need to put a 2. Hyphens always go between letters and numbers, so it's 2 methyl, to show that there is a methyl group coming off carbon 2. Then our longest carbon chain is 5, so this is pent, and it's an alkane, so this would be 2 methyl pentane. Again, as we do more of these, you should start getting the hang of this naming. Now we've got this another branched alkane. Again, I'll draw this as a skeletal formula. That's what it would look like as a skeletal formula. So again, I need to number it. 1, 2, and actually one of these carbons, one of these CH3 groups here in the brackets is part of the longest chain. That's why it's useful to draw this out as a skeletal formula as well to show this. So we've got 1, 2, 3 in my longest chain. 1, 2, 3. So remember that I said that one of these methyl groups here is this one here. The other 2 are here and here. And these are part of the side chain. So what we've got then is my longest carbon chain is prop. It's 3, so it's prop. It's just an alkane, so it's propane. And I've got 2 methyl groups coming off carbon 2. So I need to say this and say 2, comma 2. So if I've got 2 side chains, I need to put 2 numbers, commas between numbers, and then in this case, because I've got 2 of them, nearly forgot, you need to put a multiplier, and this would be di. Di means 2. Dimethyl propane. So remember multipliers if you've got more than one of the same thing. So if you've got 2, it's di, 3 is tri, 4 is tetra, 5 penta, 6 hexa, and so on. Okay, so there we've got 2,2-dimethyl propane. Next, we've got a slightly longer branched alkane. And again, let's draw this skeletally. Let's try and get this to match. It's better. Okay, so the compound that we've got there is the structural formula here. That's how it's written skeletally. So again, let's number the longest chain. And again, in this case, we want to give these side chains the lowest number possible. So in this case, we need to number it from left to right. So this is 1, 2, 3, 4, and 5. And remember that these methyl groups are the side chains. They're not part of the longest chain. So let's 1, 2, 3, 4, 5 methyl groups here in blue. And the methyl groups then are coming off carbons 2 and 3. So we'd say then it would be then 2, 3 dimethyl, 5 in the longest chain. So it's pentane. So hopefully we are getting the hang of these. So if you've got more than one of the same thing, you need a multiplier. You need to say where they are on the chain. So if you've got 2 methyl groups, you need to have 2 numbers. 3 methyl groups or 3 side chains, you'd have 3 numbers to say where on the chain they are. Okay, now I'm going to move on to an alkyl halide. We've got now a compound with other than just hydrogen and carbon in. And again, let's draw this as a skeletal. So we've got an F here, and we've got a BR coming there. And I'll just move this a little bit lower down because there's more space. Again, to number this, we need to number it so the numbers add up together to be the lowest number possible. And I'll show you what that means. In this case, I must number it from right to left. So then 4 there corresponds to the 1, 2, 3, 4 there. My longest chain is 4, so this is going to be butane. It's going to end in butane. So I can even write that down now as part of my name. Butane. And we've got fluorine coming off carbon 1 and bromine coming off carbon 3. So what we actually do is you would write these prefixes in alphabetical order. So in reality, this is going to be 3-bromo -1 fluorobutane. So let's just put this with this. So that will be the name of this particular compound. So yeah, we need to look at the alphabetical order. So the B comes before the F. Okay, so it's not about which numbers first, it's the alphabetical order of the prefixes involved. And again, this would be 3-bromo, 1-fluoro, because the numbers 3 and 1 add up to 4, which is less than if you numbered it from this direction, where you'd end up with 2-bromo, 4-fluoro, which adds up to 6. The prefix numbers must add up to the lowest number. Number 6, we've now got another halogenoalkane or alkyl halide. Let's again draw this as a skeletal. This time we've got the iodine here. So again, we want to add these up so they get the lowest number. So you would need to number it from this way. 1, 2, 3. So you need to give the iodine the lowest number possible, which again, the longest chain then is 3. 1, 2, 3. We've got a methyl group coming off carbon 2. Hopefully we realise that this methyl group cannot be on any other carbon than carbon 2. If it came off carbon 3, for example, if it went there, then it'd simply be just 4 in the carbon chain. If it was here, again, this would then in fact be 2-iodobutane. So we couldn't have a methyl group coming off carbon 2 or 3. It can only be coming off carbon 2. And with that as being the case, we would simply call this 1-iodomethyl propane. So we don't need a number this time in front of the methyl because it can only be on carbon 2. It can't be on any other carbon. But the iodine, we need to say that it's on carbon 1. So 1-iodomethyl propane. Okay, looking at number 7, we've got a couple of functional groups involved here. But again, let's draw this out skeletally, so it makes it maybe a little bit easier to see. So we've got an O there and an OH there. So again, it's a good idea that we can draw these structural formulas here and show how they can be represented skeletally as well. So again, let's number it. And again, which way do I number it? I'm going to number it, I'm going to tell you why in a sec. I'm going to number it from right to the left. 1, 2, 3, 4. So again, look for my longest chain, which is 1, 2, 3, 4. So what we've got here then, what functional groups have we got? We've got a ketone, and we've got an alcohol. Now, here we need to look at an order of priority. Now, a ketone is a higher priority functional group than an alcohol. So the ketone, well, firstly, they'll get the suffix, the end part of the name. And they also need to get the lowest number. So they have to have a lower number, number 2, than the alcohol, which is number 4. So this is bute because it's got 4 carbons in the longest chain. So we can put bute there, or butane there. We've got a ketone coming off carbon 2. So it's a C double bond O with 2 R groups. You need to recognise your functional groups. So we could say this is butane 2-O. And then we need a prefix. We can only ever have one suffix, and we need a prefix for an alcohol. So obviously the suffix for an alcohol is just ol. Prefix is hydroxy. And we need to say what carbon that's coming off. It's coming off carbon 4. So this would be then 4-hydroxy butane 2-O. Let's put that there. So 4-hydroxy butane 2-O. Okay, let's have a look at this next one. Again, we'll draw this out as a skeletal formula. So we've got this carboxylic acid here, and we've actually got two try and line it up correctly. Alcohol groups. So I'll just move this down a little bit. So a carboxylic acid has a higher priority than an alcohol. So you'd always number it from this side. 1, 2, 3, 4, 5, 6, which corresponds 1, 2, 3, 4, 5, and 6. So we've already seen then that we've got 1, 2, 3, 4, 5, 6 in my longest chain, so it's going to be hex. The suffix, okay, is given to the highest priority functional group, which is the carboxylic acid. Suffix for a carboxylic acid is oic acid, so we can write down hexan oic acid. We've got two alcohols, two OH groups on carbon 5. So we need to say that. So this would be 5, comma 5. Remember the multiply, if I've got 2, something is di. Hydroxy is the prefix for an alcohol. So this would be 5, 5, dihydroxy. Let's just put this as part of the same name. 5, 5, dihydroxy hexanoic acid. Okay, number 9 and number 10 are there. Let's have a look at number 9. Again, we'll draw this as a skeletal formula because it might make it a little bit easier for us to see. So, we've got an OH coming off here, and a Cl there. We've got an O and a H there. Skeletal is sometimes you may see this left out altogether, but it's often shown with the hydrogen present as well. So let's number this again. We need to look at what functional groups we've got. We've got an aldehyde, a halogen, and an alcohol. The aldehyde would have the highest priority, so you'd number this number 1, 2, 3, 4, 5, and 6. Yeah, 1, 2, 3, 4, 5, 6. So what we can see there, obviously, I've got 1, 2, 3, 4, 5, 6 in my longest chain. So this is going to be, again, hex. 6 in my longest chain means hex. Now, this is where it gets a little bit more difficult. So we've got hex. Now, we wouldn't need to number where the aldehyde is because they, again, like carboxylic acids, they tend to be the end. So we would assume that it's going to be number 1. But we do need to now look at this alkene. And this is a very rare instance where we can actually put this also as part of the suffix name, which is, I did say you only have one suffix, many prefixes. This is kind of the one exception where this "ene" we would put down as part of the suffix. So we should be aware, and I haven't mentioned this, but if we had something like oops, sorry, I didn't do that. If I had something like this where we've got hydrogens here and here, this would be but-1-ene, okay? If we assume that all these things I've not filled in, these are all hydrogens, you'd have but-1-ene. So we need to say where in the carbon chain the double bond is. So that would be but-1-ene. And if the double bond was here instead of there, it would be but-2-ene. Now I can use that same set of rules for saying where the double bond is in this molecule. So what we've got is the double bond here is on carbon 2. It's between carbon 2 and 3, but we'd always give it the lowest number. So this would be hex 2-ene, and then we put the al for the aldehyde. So it's hex 2-enal, which is probably as difficult as a part of nomenclature as you would get. So that's kind of the suffix part of the name done, hex 2-enal. Then we look at the prefix part, chlorine coming off carbon 4, an alcohol group coming off carbon 6. Alphabetically, the chloro is going to come before the hydroxy. So this then would be 4-chloro-6-hydroxy hex 2-enal. So it is very complex, but it tells you everything you need to know about the structure of the compound. And hopefully you can see now, as these compounds get more complex, these names get really, really difficult. And it's kind of where the IUPAC rules then get to the point where only computer algorithm can really name them. The last one, I'm hoping by now you're getting a rough idea of the rules. Again, let's draw this as a skeletal formula. So we've got the OH there. Oh, let's just count. We've got 1, 2, 3, 4. So 1, 2, and 3. So I'd have an NH2 coming off there. Let's just move this down a little bit. So we've not really looked at these amines. And the prefix for an amine would be amino. Suffix would be amine. But in this case, we've got a carboxylic acid, which is a higher priority. So it's going to be oic acid. Again, remember the numbering. Carboxylic acid's got the highest priority. So it's going to be numbered from the end with the carboxylic acid. Again, let's 1, 2, 3, 4. We've got the amine group here, this primary amine coming off carbon 3, which is the same there. And the prefix for an amine is amino, as we've said. So this would be 3-amino butan, because we've got 4 in the longest change, butanoic acid. So what we've looked at here is just some of the basic rules for naming organic compounds. And in reality, you get better at naming these the more you have a go at them. It's very difficult to cover every single rule and cover every single compound, because this would require a video of about 2 hours. It is very, very difficult. But this should be enough to get you started on naming some basic organic compounds.